Hi, I'm Sam Foster, an R&D engineer at Keysight Technologies, and today I'll be talking about the IntegraVision Power Analyzer's harmonics, topics of which I did not cover in my first harmonics video, which can be found if you missed it at a link in the video description. Now today I have my harmonics already set up, and I'll be talking about the DFT trace, how to scale its X and Y axes, and also a discussion about inner harmonics and how we actually bucket our harmonics. And if you were interested in getting at frequency content above 30 kilohertz, I'll show you how to do that with the Math FFT. So the DFT trace is actually this purple trace down here, and I'll run a single. And this tells you a lot of interesting information about the actual frequency spectrum. Looking at the left sidebar here, we see the total harmonic distortion, the source, fundamental, number of harmonics, and harmonic duration measurement period. All the numbers below here are actually specific to the DFT trace. We have the DFT peak, which is the maximum value, usually the fundamental. We have 13.98 dB here. The Y scale, which is 36.7 dB per division. The X scale, 240 hertz per division. And then a frequency reference, which is the maximum value of the Y-axis here. To be able to scale this, I'll simply click on the Math button, and you'll get some controls to be able to move things around. So this knob here will scale the Math FFT, or the DFT, sorry, up and down. I can change the offset up and down. And if you are interested in seeing this as a RMS value, you can change the Y units. Because I'm using a 60 hertz signal, I'd like to zoom in a little bit on the fundamental. So I'll change the stop frequency here to 200 hertz. And you can see the waveform is scaled for you. Now I'll be defining a few terms here. Referring to this figure, I'll be defining the pure tone as the frequency content at exactly the harmonic frequency. The inner harmonics I'll define as all the frequency content between pure tones. And a harmonic group is what this picture shows as half of the inner harmonics to the left, half of the inner harmonics to the right, summed together with the pure tone. And that is actually how we bucket our harmonics and are the values that you see in the table view here. Now, if you wanted to get an idea of what your pure tone and inner harmonics are, that's where the IntegraVision's cursor and waveform tracking mode come in handy. So I'll click here on cursors, flip the mode to track waveform, and change my X1 and X2 source to that Math4 waveform. Here, what will happen in tracking waveform is I'll move my X cursor, and the Y cursor will snap to the value there. Here I've placed my first X cursor on the pure tone, and here on the Y1 cursor readout we see 13.96 dB. To get an idea of inner harmonics, I can go and look at the 65th hertz bin, and I can see in the Y2 a value there for the 70 hertz, 75th hertz, and so on and so forth until you get to the next pure tone. This will be a very useful tool for you to look at your inner harmonics. Now, if you are interested in looking at things above 30 kilohertz, which is the frequency limit to the DFT, I'll go ahead and click on Math again, and actually look at the screen FFT rather than the DFT. Putting my box back in run mode and adjusting my horizontal, I'll run another single. And exactly the same controls for scaling the Y and X are available to you for the Math FFT. So I'll go ahead and set my scale and offset appropriately. And you can see the start and stop frequency are the same as before, but now we have a stop frequency of much higher, 2.5 megahertz. So if you wanted something above 30 kilohertz, you could easily set the start frequency to say 30 kilohertz, and maybe the stop to 200 kilohertz. And you can see the waveform is scaled on the screen for you, and all that higher frequency content is available. That's all I have for you today on the DFT trace, harmonic bucketing and inner harmonics, and the Math FFT trace for higher frequency content. And until next time, thanks for watching.